Okay, today we're going to be doing lesson 10 of chapter 1 in the Glencoe Course 3 series, comparing and ordering real numbers. It starts on page 89. You have 2 vocab terms. The first one is irrational number. And an irrational number is defined as a number that cannot be written as a fraction. Your book says ratio of 2 numbers where a over b and b cannot be 0, but we're just going to use that as our 8th grade definition. What are some examples of that? Well, we talked about how a rational number is basically everything we've dealt with so far. So all your decimals, all your percents, all your regular fractions, all of your integers, positive, negative, whole. So you're possibly thinking, what on earth could we possibly be talking about? Well, the most famous rational number that most of you have heard of would be pi. And that's why we use pi as a symbol, because in class we usually abbreviate it as 3.14. But we all know that pi is a number that goes on and on forever, has no pattern, and it never stops. So therefore it can't possibly written as a fraction and accurately be used. So we either approximate it or we shorten it, or to get an exact answer we use the pi symbol. Another one that's common that you're going to see is the square root of 2. If you type the square root of 2 into your calculator, you get 1.414213562 to infinity and beyond. Again, I cannot write this as a fraction because it has no end. There is no perfect solution or perfect way to write it. The most accurate way to write it would be to keep it at the square root of 2 because there's no pattern there. I can't just figure it out. Real numbers. So if you take the set of everything we've done so far, they would fall under the real numbers category. So it's all of your rational fractions and irrational numbers, square roots, pi, fall under the real numbers category. So you're probably thinking, what's not a real number? Well, you'll learn about that later in life, not in 8th grade math. All right, so we are going to name the set of which some of these belong to. There is a graphic organizer on page 90 in your textbook that will help you identify what these are. Example number 1 is 0.2525 ... Okay, I see a pattern here. That is a repeating decimal. So because it has a pattern, it's not considered irrational. It would fall under rational number. Well, if it's a rational number, is that an integer? No. It's not a whole number, and it's not a natural number. So rational number is the only set that it belongs to. Okay, example 2, the square root of 36. Well, the square root of 36 can be simplified to something that we know, good old-fashioned regular number 6. So don't think just because something's a square root that it's automatically going to be a rational number. 36 is a perfect square. That perfect square is 6. Well, 6 is a rational number. And I'm going to work my way into the circle here. It is also an integer. Yes, it's a positive whole number, right? It is also a whole number. And it is also a natural number. Remember, your natural numbers are like your counting numbers. 1, 2, 3, 4, 5, 6. Okay, so 6 belongs to all those groups. I would include all of those numbers along with it. Example 3, the negative square root of 7. Well, if you type 7 into your calculator, you get a very strange, non-repeating, non-terminating decimal. Non-repeating, non-terminating, there's no pattern, so it's going to be considered irrational. FYI, most square roots of prime numbers are going to be considered irrational. All right, go ahead, take a look at A, B, and C. Again, on page 90. See if you can figure out the sets they belong to. Pause your video. Well, pause the video, then see if you can figure out what sets they belong to. Log back in and find your answer. Okay, A, the square root of 10. Well, 10 is not a perfect square. If I type it into my calculator, I get 3.162277766. So I'm thinking I don't see a pattern there, and it doesn't end. Irrational. Okay, B, negative 2 and 2/5. Well, it is a fraction, and it's already written as a fraction, so I know that it belongs to rational numbers. Next inside would be integers. It is not whole, it has a fraction included, so it would not fall under the integer category. C, square root of 100. Well, the square root of 100 is equal to 10, and 10 is going to be similar to example 2. It's going to belong to all of the sets. It's going to be rational, it's going to be an integer, it's going to be a whole number, and it's going to be considered a natural number. Okay, moving on, the next set of examples is comparing and ordering these. Remember that the easiest way to compare and order them, in my opinion, is to have them in the same form. My preference is usually to go to the decimal because no matter what, it can be done in my calculator and I can figure it out easily. I'm asked to compare the square root of 7 to 2 and 2/3. Well, the square root of 7, you can put in your calculator. Rounded to the nearest tenth, you get 2.645 ... Okay, remember, it's the square root of a prime number, so it's going to be irrational. It's not going to have a pattern. 2 and 2/3 is the same as 2.666, repeating, right? It's a repeating pattern, but I know that I have enough to make a decision. The whole numbers are the same. The tenths digits are the same, but when I get to my hundredths digit, one is a 4 and one is a 6. 2 and 2/3 is larger than the square root of 7, so I would use my less than symbol in the order that it's written. Example 5. 15 and 7/10% compared to the square root of 0.02. Okay, remember, we're going to go to the decimal on both of these. To turn it from a decimal to percent, I'm swooping twice left. So I have 0.157. In my calculator, I'm going to do the square root of 200ths, which is 0.141. Now that I have the same format, they're both in decimals, they both have the same place value, I can make a decision that 157 thousandths is greater than 141 thousandths. Okay, example 6, when I have to order them, sometimes that's a little bit more difficult. I have the set, the square root of 30, 6, 5 4/5, and 5 36/100, where only the 6 is repeating, okay? So only the 6, not the 3. And I'm being asked to sort these from least to greatest. I'm going to use the same strategy though, guys and girls. I'm going to turn them all into a decimal because usually that's the easiest. When I do the square root of 30 in my calculator, I get 5.48, about, okay? I'm using the hundredths place because in my repeating decimal, it's to the hundredths place. So I want to have the same amount of place values. 6 is just 6.00. 5 4/5, we should know, is 5 80/100. And 5 36/100 is still in its original form. I can just go ahead and leave it. All right, my lowest number is definitely going to be one of my 5s. I've got 548, 580, and 536. 5.36 repeating is your smallest. Put a check mark above it so I remember that I used it. After that, you've got 5 48/100. But remember, when I put these in order, I always put them in their original formats. So I'm going to write the square root of 30 in my answer. Check that I used it. 5 80/100 is 5 4/5. And last but not least is the whole number 6. Okay? I always write my original form in my answer. I have 1, 2, 3, 4 numbers. I have 1, 2, 3, 4 numbers. Okay, once again, I want you to pause the video. I want you to do D, E, F, and G. And then come back and check your answers. Remember, if you're having problems with any of these or if you're getting them wrong, circle them and ask about them in class tomorrow. All right, for D, you have the square root of 11 being compared to 3 1/3. Well, going to the decimal. Square root 11 is 3.316. 3 1/3 is 3.333, right? Repeating to infinity and beyond. 3 1/3 is larger than the square root of 11. For E, square root of 17 compared to 4 3/100. That one's already in decimal format, so I just have to find the square root of 17. .12. Remember, I only need enough decimal places so that they're the same. I'm going to use my greater than symbol because 12 is bigger than 3. For F, I have the square root of 6.25 compared to 250%. This is 2.5. I use my calculator for that. 250%. I'm just going to swoop in twice. I get 2.5. These are equal. Okay, for G, I have negatives. So remember, your smaller negative is actually your larger number. Don't make that mistake when putting these in order. I'm being asked, I have -7, negative square root of 60, -7 7/10, and negative 66 over 9. And I'm being asked to put them again in order from least to greatest. All right, I'm gonna do all my calculator work first. Well, I should be able to do this one in my head. This is negative 7.7. And the other two I can do in my head, or I can do in my calculator. Negative square root 60. I get negative 7.745, blah, 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 okay? So we're gonna write down 2 just to be safe. Negative 7.74. And 66 over 9 is the same as negative 7.3 repeating. I need to add another 0 to 7/10, just so everybody has 2 digits in their decimal. And these are all negative. Okay, in order from least to greatest. The smallest is actually the biggest. So the biggest is negative square root of 60. Check. Then negative 7 and 70, which is negative 7 and 7/10. Check. The next largest is negative 66 over 9. And after that is negative 7. Okay, for homework, you are going to finish this assignment. Well, not finish the assignment. You're going to do guided practice problems 1 through 7, which are on page 92 in your textbook. You are going to upload those on a Google Classroom, your answers in a document, your work in a picture, and we will go over it tomorrow.